We talked briefly about this in class yesterday, but rational expressions is an extension on factoring. So a rational expression is when you have a polynomial over a polynomial, so it's a fraction. Really, all this is going to do is strengthen your ability to factor because you're just factoring. You're going to factor the top, you're going to factor the bottom like they are separate things. And then if something matches on the top and bottom, you're going to cancel it out. So it's not really a new concept. It's just kind of bringing the idea of factoring with this new idea of rational expressions. So if you want further explanation on these, here we go. So when I look at this problem, I want to try to treat it as two separate problems. So I'm looking at the top separately from the bottom. So if I were looking at this, I'm seeing a trinomial where a equals 1. So I'm using the a equals 1 method, and I'm looking for numbers that multiply to 24 and add to 11. In my calculator, I'm going to do a 24 divided by x, and I'm going to look at all the numbers that multiply to 24. 1 and 24, 2 and 12, 3 and 8, 4 and 6. And then it starts to repeat because 6 and 4 is the same thing. And then I'm adding them up. So this is 25, 2 plus 12 is 14, 8 plus 3 is 11, 4 plus 6 is 10. I'm looking for the pair that add to 11. So that's my 8 plus 3. So I would factor the top by plus 3 plus 8. And the order doesn't matter. You can flip that and do plus 8 plus 3. Now I'm looking separately at the bottom. And again, this is a trinomial where a equals 1. So I'm going to do another a equals 1 method, looking for numbers that multiply to 27 and add to 12. So in my calculator, I'm doing a 27 divided by x. 2 is a decimal, 3 is not, 4 is a decimal, 5 is a decimal, 6 is a decimal, 7 is a decimal, 8 is a decimal, and then we're back to 9. So this is really it. And 9 plus 3 is 12. So for the bottom, and I'll make sure I put it on the bottom, I have a positive 3 and a positive 9. And what happens here is the x plus 3 and the x plus 3, because they match perfectly, they cancel each other out. And then I just write the problem with what's left over. So really all this is just factoring. If anything matches out, cancels out, matches when you factor, you'll just cancel it out. So let's look at this next one. I'm looking at x squared minus 10x plus 24. This is a trinomial where a equals 1. So I'm looking for numbers that multiply to 24 and add to negative 10. Now the fact that I want them to add to negative 10 means that I'm going to have negatives. So instead of going down my list, I'm going to go up it where I'm looking at all of the numbers being negative. And so these are the numbers side by side when I do that. And then they'll start to repeat. So negative 1 plus negative 24 is negative 25. Negative 2 plus negative 12 is negative 14. Negative 3 plus negative 8 is negative 11. Negative 4 plus negative 6 is negative 10. I wanted to add to negative 10. So the top in factored form is a minus 4 and a minus 6. Now for the bottom, this is a binomial. And the first term is not 1. So this is not a equals 1. A equals 1 has to be a trinomial. So this must be GCF. So if I math arrow to the right 9 and find the GCF between 7 and 28, I find that these both divide nicely into 7. And because they both have at least one x, I can divide a single x. I can't divide an x squared because they both don't have two x's. They both have at least one. So we're using the smaller of the two x's. So 7 divided by 7 is 1. I could write the 1, but I don't have to. Keep the base, and then when I subtract the exponents, I get 1. Again, I don't have to write that. 28 divided by 7 is 4. X, 1 minus 1 is 0. The x's cancel out here. Remember, the most important part of a GCF is putting the GCF in front. So the bottom is 7x times x minus 4. You can see that I've got an x minus 4 and an x minus 4. Because they match perfectly on the top and bottom, I can cancel them out. And this is what I am left over with. I can't cancel out the x's because they're not perfect matches. One of these x's has a -6 and one of them has a 7. They can only cancel if they're perfect matches. And then the final one, I've got a 4x plus 40. Well, it's a binomial, so it can't be a equals 1. So I'm going to try GCF here. If I math arrow to the right 9 with 4 and 40, I find that they're both divisible by 4. Now, because this term here doesn't have an x, I can't divide an x out. So the GCF is only 4. When I divide a 4 out here, the 4's cancel out and I'm left with an x, and 40 divided by 4 is 10. Remember, the most important part of a GCF is putting the GCF in the front. So factored form of this first one is 4 and then x plus 10. Now I'm looking at the bottom separately, 2x plus 20. It's a binomial, so it's not a equals 1 method. I need a trinomial for that. So I'm doing a math arrow to the right 9, and I find that they're both divisible by 2. I can't divide by x because that term right there doesn't have an x, so I can only divide out a 2. What happens here is the 2's cancel out, and I'm just left with an x, and 20 divided by 2 is 10. Remember, the most important part of a GCF is writing the GCF in front. So I end up with this. Well, what happens here is the x plus 10 and the x plus 10 match perfectly. And so I'm going to write the problem without that. But actually, 4 over 2 are like terms too, and I can reduce that to 2 over 1 or just 2. So the answer to this one is 2. Hopefully that helps. This idea of rational expressions is something that we're going to continue to circle back to as we learn more and more different methods of factoring. At this point, you can work on your Math Excel numbers 1 through 16.